We've talked a lot in this class about ions and how to determine the charge on your ion. So now we're going to be going into how these ions form ionic bonds. And when these ions form ionic bonds, the charges, so the plus and the minus, must balance or cancel out when forming the ionic bond. So for some of them, it's really easy. And we've talked about sodium chloride before in this class. If we have a sodium ion, it has a +1 charge. And chloride has a -1 charge. So you bond them together and their charges cancel out. So that would be an ionic bond. Another example of one that works out very nicely is if you have magnesium, which we know has a +2 charge, and oxygen, which has a -2 charge. Their charges cancel out and they make an ionic bond. But let's say your charges didn't cancel out. Let's say you had oxygen and sodium. So now you got a +1 and a -2. So in order to make them cancel out, we need more positive charges. So the way we can do that is by adding more than 1 sodium. So now when I have 2 sodium ions, I have a +2 charge. And when I have 1 oxide ion, I have a -2 charge, and they balance or cancel out. So we'll look at a few more of these. What if I had calcium and chloride? My calcium has a +2 charge and my chloride ion has a -1. And I made these cards a unique sizes to help me figure out how many more I need of each to balance out the charge. Right now I have more positive charge than negative charge, so I'm going to need more chloride to balance that out. So this would be calcium chloride. I would need 2 chloride ions for every 1 calcium ion. We'll do one more example. Let's say I had aluminum, which is a +3 ion, and oxide, which is a -2. Right now I have too much positive. So in order to balance it out, I'll need to add more negative. But you can see if I add 2 oxide there, my charges don't balance out still. I have +3, and on the bottom I have -4. So now I have too much negative charge. So I can add another aluminum ion. And now I have too much positive, but if I add a 3rd oxide ion, that will be a balanced charge right there. So for this ionic compound, I'll have 2 aluminum ions for every 3 oxide ions. All right, so now that we know how to put ions together to form compounds, we need to be able to write out their names. So if I have sodium chloride, the important things to know are that when I'm writing down the chemical formula, I always put down the metal. And second, I will put my non-metal. So when I'm writing this down, it will look like sodium chloride. And you may notice I did not include my charges anymore because they balance out. So in all my ionic compounds, the charges will balance out. So it is a neutral compound. So another example, we could do the magnesium oxide. When I'm writing this down, I put my metal first, which is magnesium, and then oxide second. Magnesium oxide. Now, for examples in which I have different amounts, so when I had calcium and my chloride ion, if you remember, I needed 2 chloride ions to balance the charge out. So this one will be a little different, so I have to write that 2 somehow. So I have 1 calcium, so I write that the same way, my metal first. And then to show that I have 2 chloride ions, I write chloride and a subscript 2. So that 2 tells me how many I have in this ionic bond. We could do another one. We could do potassium oxide. So for this one, the charges don't balance out. I'll need to add another potassium there. So I got to put my metals first. So it'll be potassium, and I have 2 of them. And then I have 1 oxygen. And then in our example with aluminum oxide, you remember sometimes we have multiple of more than one type. So in aluminum oxide, we had to add multiple oxides and multiple aluminum to balance our charge out. So for something like that, we would have aluminum 2 oxide 3. So I'm going to go over one more. I'm going to go over an example with a transition metal. So let's do one very similar to one we just did. We'll use iron oxide. So this would be rust. So iron oxide is another word for rust. So very similar to aluminum because iron 3 has that same charge. And when I'm writing this one down, I don't even have to put that 3 anymore. If I just put Fe2 O3, I have all the information I need there because I know my oxide has a -2 charge and I know I have 2 iron ions. So just by this information here, I could tell I have iron 3. So this is just how you write it, just like that.